The title of this video is Lewis dot symbols. In this video, we will discuss Lewis dot symbols as a way to represent atoms and simple covalent molecules. Lewis dot symbols are representations of the valence electrons of atoms. Valence electrons are those farthest from the nucleus and are involved in bonding. Here are some examples. Notice how the atomic symbols of the element are surrounded by dots. Each dot represents a valence electron. Lewis dot symbols are related to atomic orbital theory. In this way of viewing atoms, electrons are divided among orbitals. These orbitals have names such as s, p, and d, and are filled in a particular order. Each orbital may contain 2 electrons. A full orbital has both electrons, an unfilled orbital has 1 electron, and an empty orbital has no electrons. All of this information is organized and conveyed by the electron configuration of an element. This table shows how the number of valence electrons is the same within a group of elements. On the left-hand side of the periodic table, groups 1 and 2 have valence electrons in s orbitals. The next section of the periodic table contains elements with valence electrons in unfilled d orbitals. These elements are not represented by Lewis dot symbols. The third section of the table has elements with valence electrons in unfilled p orbitals. And the last section is the noble gases. All of their orbitals are full, and they have the most stable electron configurations. This means they do not participate in bonding. So how do you draw the Lewis dot symbol of an atom? First, you write the atomic symbol of the atom. Second, you determine how many valence electrons it has. Third, draw dots around the atom, 1 dot for each electron. Spread out the electrons among the 4 sides, but do not exceed 2 electrons per orbital. Take a look at these Lewis dot symbols for atoms, and see if you can determine which 2 symbols are incorrect. Now we will discuss Lewis dot symbols of molecules. As stated earlier, the noble gases have the most stable electron configurations. Their s and p orbitals are completely full. Other atoms would like to be as stable as the noble gases. In order to fill their orbitals, they share electrons with each other. This is called covalent bonding. The result is the formation of a molecule. The most important thing to remember about Lewis dot symbols for molecules is that all atoms want 8 electrons, except for hydrogen and helium. They only want 2. This is called the octet rule. But remember that we are not including any of the transition metals, also known as d-block elements. Here is an example of how to draw the Lewis dot symbol of a simple covalent molecule. First, we draw the atomic symbols for nitrogen. We want to demonstrate how these 2 nitrogen atoms will bond with each other. Both atoms have 5 valence electrons. This means they each need 3 more electrons to form an octet. To achieve this goal, each nitrogen offers 3 of its electrons to share with the other. We show this by rearranging the electrons and drawing circles around the atomic symbols, encompassing all 8 electrons that each atom has access to. Notice how we started with a total of 10 electrons, and we still have a total of 10 electrons. This is important. Electrons should not be added or subtracted. After you've determined that your drawing is correct, rewrite the atomic symbols and replace each pair of electrons in the overlapping circles with a line. Also include any electrons that are not being shared. Here is some relevant vocabulary. A bonding pair is 2 electrons that are being shared by 2 different atoms. Those are the ones in the overlapping circles. A lone pair is 2 electrons that are not being shared. They belong solely to 1 atom. An unpaired electron is simply a single electron. Here are the steps to drawing the Lewis dot symbol of a molecule. First, draw the Lewis dot symbols of each atom. Second, determine how many more electrons each atom needs to make an octet, or a pair for hydrogen. Third, make your best guess for how to arrange the atoms so that everyone is happily sharing their electrons. Fourth, Check your guess by drawing overlapping circles around each atom encompassing all 8 electrons, or 2 electrons in the case of hydrogen. Fifth, rewrite your solution without circles, replacing each bonding pair of electrons with a line. These are the electrons in the overlapping circles. Now take a look at these Lewis stat symbols and see if you can recreate them.